Hello everyone. In this video lecture, we are going to see the term coherent sources. This coherent source is used to show the phenomena of interference. So before to see the coherent source, let us see what is the interference in short. Interference is formation of two things. The first thing is constructive interference. Formation of constructive interference and destructive interference. And this phenomena is based on principle of superposition. Interference is based on the phenomena, and the condition of interference is the condition of the interference which is based on the principle of superposition to form constructive and destructive interferences. Interfering wave must have same frequency or wavelength and have a constant phase difference with respect to time. Two conditions. So see carefully. Here is needed a source of light which have a same frequency producing constant phase difference to produce the phenomena of interference. Normally and generally it is said that we are using monochromatic light for this purpose. Monochromatic light refer to the light of single color, or we may say of single frequency or single wavelength. Monochromatic, if you take only color has a range of frequency, but need of range of frequency is not required. Exactly same frequency is required. Here in Young double slit experiment, we take a source, monochromatic source here, yes, and we take a hurdle, obstacle, keeping one slit. Then in place of this slit becomes source of monochromatic light. Normally we take sodium lamp for this purpose. We take a screen to show the interference pattern. In front of that, one more obstacle is kept. Straight in front of the monochromatic light, two slits are made, S1 and S2. This two slit becomes two sources. These two sources, S1 and S2, both are virtual sources. Clear? These two virtual sources of same source, yes, real source is this. As a result, what happens is both producing ray of light here and meeting at point P, where phenomena of interference pattern is obtained with help of the telescope T. Right? Two waves. Here both virtual waves emits light of same frequency and constant phase difference, and producing these two see in the box is the condition to produce interference pattern. When this situation occur, see carefully, then these two virtual sources is said to be coherent source. Here both virtual sources are coherent sources here in this case. One more method is used to obtain the phenomena of interference, that is Lloyd's mirror. This Lloyd mirror, a mirror is used, plane mirror, thick plane mirror is used, and monochromatic source suppose is here, and let's see, one screen is kept here. In this screen the interference pattern is obtained. We are taking a beam of light falling from first end to last end of the Lloyd's thick mirror, and from the plane of this mirror the phenomena of interference patterns takes place. From here this on the screen. Now see, once one view from here, when we proceed this both reflected ray backward, both rays seems to come from a common point here, S dash. So here two sources produces this source S, which is a real source, and source S dash produces here, that is virtual sources. The phenomena of interference pattern is obtained. Now let us see, these are the things when this produces here. In it we may take one direct ray reaching on here, one ray passing at the last. So the common area is this by both, where phenomena of interference pattern taking place, which can be viewed through the telescope here. Now see carefully. In light mirror, two sources is, one real source and one coherent source. Yes, S1. S1 is real and S dash is virtual, and this both sources is here coherent source, which produces light of same frequency and constant phase difference, which is the condition to produce interference pattern. So two coherent sources can be only both is virtual source, or one is real and another is virtual. But come here in the topic. No interference by two independent sources. If we have two independent source available. In case of two independent source, let source 1 and source 2. If both two independent source, then discuss on the source number 1. The source is made up of atoms, and we know that in this atom there is a nucleus and electrons are revolving around it. These electrons, outermost electron, have various energy level. If one electron is outermost electron moves from lower energy state to higher energy state, after acquiring the energy, then it's come back, right? And they stay in the higher energy state for 10 to the power minus 8 seconds, and they come back and emits radiation. This radiation is a light radiation of frequency, appropriate frequency. And when we take this source 2, it can also be made up of atom. In this atom there is a nucleus and electrons revolving around it in various orbits. Their energy level may be different. When they move from one energy state to a higher energy state, and after leaving in 10 to the power minus 8 second here, again came by, and when they emit the radiation, their frequency cannot be equal to the first one. So if frequency is not same, so both have a different frequency. Different frequency is not a condition of interference. For interference pattern, same frequency is needed. So if frequency is not same, then phase difference cannot be seen. See carefully. That is why the written here, two individual sources, two independent light source cannot produce interference. No interference by two independent source. It can be obtained only coherent sources. The coherent sources produces in Young double slit experiment, and second condition of coherent source is one real and one another. In case of light mirror, when we see phenomena of interference pattern in here, right? So here these two sources, when we are using these two sources, is said in coherent sources. So incoherent sources cannot be produced phenomena of interference. It can be produced only by the coherent sources, either in case second or in case first. This is for the topic. Thank you and have a nice day.